Good morning, guys. Welcome to a pink sunrise kind of morning. It's weird out here. I'm not going to spend too much time out here. Right now, as far as particulate matter, the sensors are telling us it's actually not too bad, but yesterday was one of the worst air particle days we've had in Sacramento. Some of the sensors were just reading at the top of the charts. With all the smoke and the wind that was going on in the last couple of days, you can see my yard is an absolute mess. So we've got a lot of stuff that's up in the atmosphere. So if you're feeling ill, if you're feeling a little run down, it may well be because of what you're breathing. So stay inside if you can when those days come along. Pay attention to them, and let's talk a little bit more about what's going on with fires and what's happening in our atmosphere. Colorado yesterday had an incredible temperature swing. So right here's Colorado, that's the one in green. Colorado, and over here we got California. Now, they went from a weekend where they had temperatures 99, 100, 101, and these are record high temperatures for this late in the year. Usually they're cooling down at this point. But for some reason, it was really, really hot in Colorado and hotter than it's been on record. But the next day, it starts cooling down, and by Tuesday morning, they had snow. They had 1/3 of an inch of snow, and I'm going to show you what 1/3 of an inch looks like. Here's a ruler, and if I put my finger right there, actually let's do my little finger. Put my little finger there, 1/3 of an inch, about the thickness of my little finger, maybe a little bit less. That's not much. That's how much snow they had, but it was significant because it was the earliest they've ever had snow in Colorado in the records dating back to 130 years. So we have extreme high hot and extreme low cold. What does this mean and how does this happen? So you know we're battling wildfires here in California, but Colorado is also battling wildfires. And I'll show you a picture right here. Here's what California looked like, and here's all of our wildfires. And here is a picture of Colorado with their wildfires. And they have wildfires, and it's putting a lot of smoke into the air. It's also putting some gases into the air. So we need to understand how does the smoke and the gases affect weather. Okay, so first let's think of anything that goes into the atmosphere is like a blanket or a jacket. It's something that covers the planet. As we have different things going into the atmosphere, it's going to change the way our planet responds. So one of the things that we like to have in our atmosphere is this. This is an oxygen molecule. 2 oxygen atoms put together make an oxygen molecule. And as oxygen's going around the atmosphere, it's actually pretty easy for sunlight to get in, and then sunlight hits the ground and it'll bounce off. Energy in, energy out. It goes back and forth pretty easily. Some other gases, though, that are released by fires are not released so easily. So, for example, we have carbon plus oxygen. This is carbon, this is oxygen. This is called carbon monoxide, and this is what we call a greenhouse gas, because when this goes up into the atmosphere, the light comes down and then it gets insulated. It doesn't come back out. In fact, when the energy from the sun that's reflected off the ground tries to come back out, it actually heats up the carbon monoxide and it holds in the heat from the sun. We also have carbon dioxide, something you and I breathe out. It's got 1 carbon and 2 oxygens. This is something also released from wildfires. This also contributes to greenhouse gases. And then, of course, yesterday we talked about methane released from the breaking down of plant materials that microbes in Siberia were doing. This is another greenhouse gas, and these are creating layers over the earth that are heating it up and insulating, keeping all the heat that's there inside. So putting on layers over the earth is like putting on extra jackets. We got a jacket there. How warm would you be if you dressed up like that? Yeah, this is fine, sure. So with all these layers of insulation, the earth is holding in the heat that it got from the sun. But if you still have wildfire, then that's adding more heat because that's literally heat from the fire. So you have this heat underneath the jacket that the Earth has, and that's keeping Earth really hot. So that would account for a lot of the heat that's going on. If you also have a dry season where there isn't a lot of rain and the plants are looking kind of dry, that water that's not in the plants would normally absorb some of that heat. There's no water there to absorb that heat, so extra heat is going to be in the ground and in the atmosphere, and that's going to be something that contributes to these record high heat levels. There's another factor though that leads to our cooling. If you have a cloud over the top of something, the cloud actually reflects light. So the dark is going to absorb, and the white clouds actually will reflect the light back into space. And if you have white clouds or particles like smoke particles will also reflect light back into space. So once you have that, you have something that is going to reflect light, keep the heat from getting down to the Earth, allowing the lower layers of the atmosphere to cool down a little bit, and that's where you end up with a cooling trend, where suddenly what used to be a really hot trend is now getting cooler and cooler. That's it for today. Go ahead and check out these links, learn a little bit more about greenhouse gases and insulating the Earth, and we'll talk to you soon. Bye.